In this section, we're going to talk about what exactly is programming, what makes up a program, and what exactly is a programmer versus a user, and kind of why should we should do some programming. And so yeah, let's get started on what exactly is a programmer. Whether you're a beginner programmer or you've been programming for quite a while and you just want to learn about Python, there's something that you probably didn't really notice is that you've probably been programming your entire life. So, for example, let's say you've been playing a board game. If you've been playing a board game, then you've essentially been executing a program, right? So, a board game has inputs, a set of inputs, and then a specific set of commands and things that you have to follow, and you make some decisions along the way. And then there's a specific output, and finally there's a conclusion. Somebody won, right? Well, that's really just what a program is. A program is just a set of inputs that you then work with and define that. I really like this meme that I have here that says, I prefer the real beginner programming language. And it shows there, I think this is, there's kind of like a set of these outlined commands using UML style. And he says, I said the real beginner programming. And so then he switches over to Scratch, which is like a pretty common, really beginner program. And then he says, no, I really mean it. And then it goes in and it shows that marble tool, right, where it falls down, and he says that's perfection. And that's really true. Like, even, I have a 4-year-old son that has this marble puzzle. It looks just like that, and we can put it together. We can change it all we want and do all these sorts of really fun things with it. And he's learning how to program is what he's doing there. So computer programming is essentially the process of designing and building an executable program to accomplish a specific computing result. So you take these set of inputs, you process them, you work with them, and then you have an output that you then present to your user, and whoever or whatever that may be. Programming is writing instructions for a computer to do. It's literally like a language, and it is because the Python is a programming language. There's a set of instructions that you learn and keywords and things that you string together to be able to make a computer program to do something. Programming is done using these different languages. Python isn't the only one. There's multiple other ones, and I'm going to show you some examples of what those different programming languages are. Just like linguistic languages, the programming languages are kind of built off of each other. There's some similarities between a lot of programming languages, and then there's some things that are really, really kind of different. And one thing to take away from this is once you understand the core concepts of programming, changing languages becomes easier most of the time. There's syntactic differences, but just like in languages, if you learn a romantic language, so say you learn Spanish, you're able to pick up some of the other more romantic languages a little bit easier because you understand how that works. Well, this is kind of the same thing. I've come to realize that after learning C, I was able to pick up Python fairly well and kind of make that translation. And that's because Python is built on C. The CPython instance of it is, at least. And vice versa. The more I learn Python and then kind of get into the depths of that, I've been able to learn C a little bit better. And that may work for you in some of the other languages that are there as well. So what exactly is a programmer? Well, a programmer is also sometimes called a coder, but it's a person who creates a computer software. Well, all right, well, duh. But what really is a programmer? Well, a programmer is a critical thinker. It's somebody that has to think about what is the problem that I'm trying to solve, and how do I solve that problem using a programming language. It's an engineer. They construct these massive solutions. A programmer is an artist. And this is kind of something I don't think a lot of people realize, but programming is an art. When it's done really, really well, when you look at a good code base and you're a computer programmer, you can kind of see that that's a work of art. Whether that's the way that it's laid out and it looks nice, or maybe it's an algorithm that just is really kind of neat and does this new kind of thing, or does something very efficiently. art really is a major part of programming. Programmers are problem solvers. They take these problems and they think about them and they solve them using these programming languages. They're a storyteller. And what I mean by that is oftentimes you're going to use programming to try and tell a story, to perform certain actions. Data science is a huge deal right now. Learning about a lot of how things work and interact with each other. By using programming, you're telling that story of how those different numbers and different data sets are all related to each other. A programmer is unique. No one programmer is going to be the same. The way that I program is never going to be the same way that you program. And neither will you be able to program the way that I do, or to be honest, the way anybody else does. And that's great. That's what makes programming so interesting and so neat, is even though there's a set of defined constructs that we have to work within, no solution really is going to be the same between the two of us. And that's okay. That's kind of what makes programming really, really neat. And I really want to point out that you are a programmer. By just taking this step, by just learning the first beginnings of this, you're now going to become a programmer. A programmer isn't always an expert. And there's going to be times that you're going to kind of go in between these kind of two states. And as you progress, you're going to flip and flop between these. As you start to learn new things and start to implement these things, you're going to think, I am literally God. I can do all of these amazing things. And then once you first hit that execute button and you get the errors and you just realize, I don't know what I'm doing, or you look at Stack Overflow and realize, what does this even mean? All of a sudden you realize, I have no idea what I'm doing. I've been working with Python for over 10 years now. I've been working in a setting as a programmer for probably about 11 to 12 years now. I still flip-flop between all of these. I've met people that have been doing software engineering for 30 years, and they tell me that they still flip-flop between these two states. Don't ever let your setbacks as a beginner programmer hold you back. Push through them. Because I promise you that as you do, you will be able to reach those moments where you're like, wow, this is amazing. I'm able to do this. And more you'll fade into this, I really know what I'm doing, and not so much the, I don't know what I'm doing. What is a user, and why is a user really important? Well, a user is anything or anyone that executes your code. You can be your own user. The user is your customer. It's the person that's going to be really working with this. And it's really kind of important to understand, what are they thinking about? It's kind of an example. Think about, if you wanted to design a cup, and you have this cup, right? And you want to design it and look for it. Like, how's this person going to use this? You might really think about, how is this person going to use it? What's the shape going to do? How big is the opening at the top so they can maximize the flow? Is it going to be too big so that if you try to gulp it too much, you don't want it to fall, all over their face? Is it going to be kind of a funky shape just to make it look neat? Or is it going to be economical? What about how to clean it? Those types of things. Think about everything that it might be doing. One problem, though, is the user is also going to be the most difficult problem that you'll face. And you might run into somebody like this who doesn't know how to use a cup. and you need to be able to be prepared for that. Anticipating your user's needs is going to be the biggest challenge you'll ever face, especially when that user is yourself. But it's also going to be the most rewarding. Some of the greatest moments of my life has been delivering a package or delivering a software delivery to someone and them just being excited about what the features that they have and what's accomplished with this. And so it's going to be really the most rewarding. So a user is going to be anybody that uses, and even anything that uses, your code. Let's talk a little bit about programming languages. There are hundreds of programming languages. Let me click on this link to show you here. This is Wikipedia's list of programming languages here. There's a lot of them. Some of them are more familiar than others, but there's just a lot of them out there. And trying to figure out which one is the right one can be kind of daunting. But ultimately, all programming languages come down to the one thing. They convert statements into machine code. Your computer, the way that it works is ones and zeros. It's either an on or off state. And everything that you program in there eventually just comes down into one of those on and off states. There's also two major types of languages out there. There's the compiled language, which basically takes the instructions that you have and they translate them into machine code, and then they're executed. And then there's interpreted, where those instructions are then parsed or translated and then immediately executed. And the difference between the two might kind of seem a little bit not the same, or make kind of seem the same, but not really understanding. A compiled language is essentially, you have two steps to it. You have to take those statements, and then a compiler compiles that into the machine code. And then what you do is you execute it. Interpreted languages, they kind of just do that on the fly. And most of the time, interpreted languages are built on the backbone of another compiled language. So oftentimes, interpreted languages have more resources to them. They sometimes take up more memory. They sometimes take longer to execute. One of the biggest issues that a lot of people face with Python, or at least complain about Python, is its execution time, and how sometimes that doesn't execute as fast as other languages. It's kind of up in the air, on my opinion. I mean, I'm kind of biased, but there are definitely situations where Python definitely doesn't make it, and you need to go to a lower compiled language, such as C, which is what Python is built on. It is built on top of C. This is kind of just a funny little graphic for you to talk about the differences of Python. For example, in Python, this guy says he's talking about this report that he's turning in to this professor. And if it was Python, what he does is he says, this is plagiarism. You can't just import essay, right? And that's the kind of the beauty of Python is most likely there's a library already created to do what you want to do. And all you have to do is just take these Lego pieces of these different libraries, piece them together, and then it does the specific thing that you need to do. In Java, I really like to dog on Java. I'm not a big fan of Java. I understand Java has its places, but I really like this one. And it says, in 2 pages in, and I still have no idea what you're saying. In C++, it says, I asked for 1 copy, not for 400. My other favorite one is HTML, which says, this is a flower pot. And the reason why I really like this is because HTML really isn't a programming language. It's a markup language. And so you really can't do any actual programming with it. Oftentimes, HTML is banded with JavaScript, which is a programming language. But a lot of people think that HTML is actually a language. It's just kind of a funny graphic to kind of break this up a little bit. Let's go over some of the examples of those different languages and how to say hello world. Hello world in the programming world is just kind of like the first thing you always do, right? And all you're doing is just outputting to the console the words hello world. So let's see how we do that in the different languages. First up, here's C, and this is what it looks like. We have to include this package that's in there. We have this main function that's in there. And then we do printf, and printf displays the string, what's inside of that, the quotations that's inside of there. And then finally it returns. And this is how you print or output the string hello world to the console. Next up, here's Java. So we've got a class that's my first Java program. Inside of that, we have a main. And then finally, we have the system.out.println or println. And then here's hello world there. Next up, we've got C#. C# is actually another language that I really enjoyed programming in. And I think it's a great kind of fun programming language to work with. This is how you would do it in there. You have a namespace that you set. You have you create a class for that. Inside of that class, you have your main loop that's inside of there, and then finally you do system.console.writeLine in there. Here's how you do this in Python. One line, print hello world. This to me is the beauty of Python, is it strips down all of this kind of stuff that just takes up a lot of space and a lot of complications, and reduces it down to how do we do this in the most simple way possible. And that's how you do it. And this is how you do print in Python. So let's finally talk about, why should you learn how to program? What are the reasons why you might want to learn how to program in any type of language? Doesn't matter whether it's C or Python or Java or whatever it might be. First, I want you to ask and pause this video for a moment and think to yourself, why are you wanting to learn about programming? Before I go into any of these ideas and any of these things that I came up with, think about to yourself, what is it that you want to do? What is it that you want to get out of this? The first thing that I came up with was to get paid. Software developer, according to the US News, has the #1 best job. It's the #1 in best jobs. It's the #1 best STEM job. And it's the #1 best technology job. It's also one of the highest paying jobs that's out there. The median salary is $103,000. That's out there. And it has a very low unemployment rate of 1.6. This was as of just a few days ago. I checked this and checked it out. So becoming a software developer is a pretty good thing. It's a good job security, and you'll have plenty of jobs out there. Next up, you might want to automate some stuff. Have you ever encountered where you're doing something inside of Excel and you find you're doing the same thing over and over and over again? Well, maybe you want to automate that. And maybe you want to learn how to do that. Programming allows you to do that. In fact, programming is perfect for automation and trying to figure out those types of things. There's been plenty of times in my life where I've had to automate something. In fact, right now, I work for NASA's Jet Propulsion Lab, and I have to grab these metrics from all these different places. Every week, I have to do this. And I got tired of doing that, so I wrote some Python scripts to automatically grab the metrics that I need, calculate what they need to do, and then puts it up to where I need to do it. It saves me probably about 20, 30, maybe even an hour worth of my time, all done within a few minutes. Maybe you want to be creative. Just create something. There's something just really kind of neat about just putting something together and creating that, and just thinking about your imagination. Gaming might be something that you're interested in, and programming for gaming, that's a big deal. Maybe you want to create a new tool to be able to help somebody else. Whatever it may be, creation is a huge reason why you might want to become a programmer. Finally, maybe you want to make change. I'm going to drop into this link here. And what this is I actually encountered this when I went to PyData LA. And this is a kind of a socio-economical look in data science. And it's talking about homeless shelters in San Diego. And it started talking about how many people and things are kind of happening with that. And this has a set of graphs to be able to talk about this very thing. And so this is what we're viewing here is actually a Jupyter notebook that does some calculations and then has some graphs that's displayed here. Here's downtown San Diego, homeless sleepers. And you can see where in downtown San Diego has the highest concentration of homelessness. And this is really important because it helps lawmakers to be able to make decisions. And that's kind of a big deal to be able to understand that. And it's really important to understand how that works. So you might become a programmer to elicit change and make that change. And that's an awesome thing to be able to do. So let's take this journey and think about, what do you want to be when you become a programmer? And now that you have become a programmer, what are you going to do with this new responsibility, with this new power that you've been given? And how are you going to wield this to make a better world for yourself, for those around you? Hopefully we can all do a little bit of something better with this. I'm excited to try to figure it out, and I'm excited to teach you on how to do this. Next up, we're going to learn about the basic components of computers and how they operate with each other. So let's get started with that.